Okay, next we'll move on to finding the next value, which is a value of L, the inductance. So as the previous example, for this one we are going to need this equation here. Okay, so we already have all the values that we need over here, so we can just substitute all the numbers to find the inductance. So finally we will have the inductance that we need to put for this buck converter in order to get the said input voltage, the said output voltage from the input voltage. We need this value. Okay, so next is the RMS value for the capacitor current. Okay, so again we will use the um, waveform of IL to get the information for IC. Okay, so here IC. Okay, so for the capacitor current, the shape of the waveform is exactly as the same to the uh, IL. Okay, so but here, since the average value for the capacitor current will always be 0, okay, so the midpoint for this waveform will be at 0. Okay, so average of IC is equivalent to 0 ampere. Okay, so here we also already knew that the height here is the height of this from peak to peak, lowest peak to the highest peak from the previous solution is 8 ampere. Okay, and since this is at the midpoint, so here this will be 8 over 2, and then this will also be 8 over 2 and minus. Okay, so here the maximum IC max is 4 ampere. IC minimum is minus 4 ampere. Okay, so for the RMS, IC RMS, we are going to need the maximum value, this one. So IC max over power of 3, not 2. Okay, so this will be 4 over, so finally this is 2.3 ampere IC RMS. Okay, so for the next one, we are still going to need to be needing this waveform over here, and this one we need the capacitance value. Okay, still remember the weird equation that we have last time. So this is the equation with shaded area over C. Okay, so again this shaded area over here is this area. So we are going to need the this width over here. So for that we are going to need the period T Okay, and half of that will be this T1. Okay, okay, so T1 is 2 over 4. Okay, so why 2 over 4? I already explained in the previous example, so you can refer to the previous video. Okay, so this one will be half, so 12.5 microsecond. Okay, then we are just going to find the shaded area from that. Okay, so this is equivalent to CS. Okay, so in order for us to have the buck converter with the said condition, we have to have the capacitance as 5 millihenry, and just now we also have calculated the value for the inductance, which is this value over here. Yeah, so that's all.